So our objective today, we've gotten quite a few, is we review product rule for exponents. We just did that. We're going to review writing values in scientific notation. You guys are pretty good with that. You're going to understand the process and successfully perform multiplication of two numbers in scientific notation. So notice that our option for our objective is not to rewrite the numbers in standard notation and do math. That's not what we're going to do. Okay, Jacob, that backpack needs to go into the front, please. So we're going to focus in on the third objective. Oops. Go back to black. And we're going to be understand the process. And successfully perform multiplication of two numbers in scientific notation. This is the whole reason why we study scientific notation, so that we can do math with it. And this is why scientists created it, so they could do math without having to contend with all those extra zeros. Okay? Now again, we're going to talk about all four operations, adding, subtracting, multiplying, and dividing, because the whole point to doing scientific notation is to be able to do the operations. And multiplication and division, I think, actually are the two easier operations, as opposed to adding and subtracting. Now, this comes out of that lesson 2.4. So if you want to just zoom to that when you're doing your studying tonight, Caitlin. And again, they don't have super good examples for both of these. The example 2 is the one to pay attention to in the lesson. That's the one that deals with multiplication and division. And they have, I think it's just a division problem that they show. So one of the things that the scientists want to study is, comparing distances. And so that's where they need to know how to do division. And they're going to need to know how to do multiplication. Okay, so what we're going to do is talk about that process of the problem we just solved. We're going to show the problem in our notes, and then we're going to talk about in words. Now, I'm also going to give you some problems that are going to cause issues down the line, meaning the answer you get may not be the final answer you need to give, okay? So let's go back. Let's say we had 2 times 10 to the 5th. And we wanted to multiply that by 1.3 times 10 to the 4th. And Casey very accurately said, take the coefficients, which are the decimal parts, the 1.2 and the 1.3, and we're going to multiply them. Now, do you notice how weird that looks with the dot for multiplication versus the X for multiplication? It looks like it's a misplaced decimal point. Okay, but again, I'm trying to make a distinction between the X for multiplications in the scientific notation. So we'll put him back in blue. And then on our powers of 10, because we are multiplying, the product rule says we're going to end up adding the exponents. And then off to the side, we just do 1.3 times 2, and remember with multiplication and decimals, we do not line up decimal points. We pretend the decimal's not even there. We just multiply 13 times 2, and we get 26. And then we go back and we count up how many digits came after the decimal point originally in the two numbers together. I only had one digit after the decimal point, so that says my answer will get one digit after the decimal point. So I get 2.6 times 10, and 5 plus 4 is 9. Now, before I can say done, I do need to make sure that my answer meets the criteria for scientific notation. The big place we have to watch is in the number part. Does it fall between 1 and 10? Is 2.6 between 1 and 10?
Yes.
Yes. So that means my answer is exactly what I need it to be. Okay? So that's what you guys are going to be working on. Now, I'm going to go ahead and we're going to move when everybody's ready with that problem, and we're going to write down just in general this process that we're going to follow. Is everybody ready? Sophia.
So that's the only way to make sure our answers tonight?
Your numbers will stay in scientific notation while you do the math. Your answer will be in scientific notation, so you will not be asked to write it in standard form or standard notation. Or I read someplace else, decimal notation, which seems weird because usually you take out the decimal when you get rid of the power of 10, but whatever. All right, everybody ready? Mm-hmm. Okay. So our process was pretty simple. Number 1, leave values in scientific notation. The whole point to us learning scientific notation is to do math in scientific notation. So you're going to multiply the decimal values, and I'm going to put in parentheses what it's like if we were just doing a regular math problem. They kind of take, it'll come back. It'll take the role of coefficients. Okay? It'll take the role of coefficients. So when we were doing in our old problem 2 weeks ago, when we were talking about just rules and we're talking about the product rule, we would multiply the coefficients. And then we would add the exponents on the base of 10. Now, sometimes your numbers will have different signs, so that means you'll actually end up subtracting them. Okay? So we have to follow integer rules as we do things. And then rewrite the answer in scientific notation. So that means we're not going to expand it out. We're going to have what they call the decimal component and then times the power of 10 component. So I'm going to give you a warning. Be sure the decimal value is between 1 and 10. Now, between means it can't be 10. It's all the way up to 10. Aaron, you taking notes, buddy?
So it's 1 through 9 or 2 through 9? 1 through 9, right?
1, yeah, anything that has a 1 to anything that has a 9. And then it could have decimal pieces after that. Okay. So what I want to do is find an example. Okay. So here's an example where the blue star comes into play, okay? And we have to figure out how to deal with it. Oh. Okay, so here's a situation in which in real life scientists would use this. So let's say you have an adult blue whale that can eat 4 times 10 to the 7th krill in one day, and krill is just what? It's like little shrimpy things, okay? Not exactly shrimp, but like shrimp, okay? And it says at that rate, how many krill can an adult blue whale eat in 3.65 times 10 to the 2nd power days? So what we're going to do is we're going to take the amount of krill in one day and multiply it by this amount in this many days, and that's how we're going to get it. So we have the first whale. We've got an adult blue whale can eat 4.0 times 10 to the 7th krill per day. Now, what I'm going to demonstrate to you is something called dimensional analysis. You'll get into it more in the next class, but we'll keep using it. And I can use that dimensional analysis with the labels to help me set up my problem. Next, it says, well, how much would it eat in 3.65 times 10 to the 2nd days? So what you should notice is that when you're multiplying numbers that have labels, the labels also you can do math with. We wanted our answer was how many krill could he eat, so we needed to get rid of the days. Sophia?
Do we have to write like 0.0 before?
No, I'm just, with scientists, they tend to go to the nearest tenth, seems to be a default number that they go to just to show you accuracy. And that's something else we'll talk about in subsequent classes, talking about accuracy and precision. So what we're going to do is just look for the key values. So the two numbers that we're going to multiply are going to be these two numbers, the 4.0 and the 3.65. The exponents we're going to deal with are on the basis of 10. So we're going to deal with the 10 to the 7th times the 10 squared. This guy in the middle tells me what math to do, okay? So when it comes to, and I'll just show the problem out, we've got 4.0 times, 3.65. And then I would have times 10, so this is always going to be part of the problem, is that times 10 is going to be in my answer. And then I've got 7 plus 2. Now at this point I've eliminated days, so my answer just would be in krill. Now normally I don't worry about my labels till the very end, but I like to write my equations with the labels so I make sure that I have the label I need for my answer. And then I usually don't write the label until the very, very end. Jacob.
Why didn't they teach us this in like 4th grade when we had to because we were just learning how to multiply and we had these huge numbers and it was easy, but it would take a million years just to do one problem.
Because we need to learn all different grades of a problem. So there's a purpose behind doing that. And you're right, once you kind of get this idea, you're like, this would be a lot faster. But a lot of times the numbers you had didn't have zeros. 123 times 24, 1.23 times 10 to the 2nd times 2.4 times 10 to the 1st. You're not saving yourself much trouble from there. Okay, so
Only 1 or 2 zeros.
right. So when I'm actually doing the math here with the decimal parts, I'm just going to multiply. And temporarily, I just look at 365 and I look at 4. So I look at only the non-zero digits. So I have 20, I have 24 and 2 is 26, 12 and 2 is 14. Then I go back and I count how many digits came after the decimal point. Let's see, this one we didn't have any. Here we had 2. So my answer would also need 2. So at this point, and I don't need to write that last 0, I have 14.6, oops, let's go back to black on those guys, times 10, and 7 plus 2 is 9. Okay, now, but I'm not done. Yeah, I'm not done, so I'm not going to worry about my krill to the very end, but krill, yes, at this point is still what I am dealing with. Now, what's the problem with the blue answer, Kelly? What's wrong with the 14.6? Zeros don't matter. There's a much bigger problem with 14.6. Mark?
It's above 10.
It's above 10. So what we're going to need to do now is to rewrite this portion into scientific notation. And then I'm going to show you kind of a shortcut. So how would I write 14.6 in scientific notation? Connor? That wouldn't be scientific notation because that's now definitely over 10. Okay, we need it to be between 1 and 10. Okay, Sophia.
Do the decimal first to the left.
So we're going to move 1 this way, and that would give me what?
1.46.
Now, I moved it, and I need to give an accounting for the one that I moved it. So now this is where what we talked about last week comes really into play. Either I moved it a positive 1 or moved it a negative 1. How I determine the sign is what kind of number did I have. The big telltale between the kind of number I had is what do I see first. If I see a decimal point first, or I see a 0 and then a decimal point, that's a very, very small number. If I see a number first, that's considered a very large number. Okay? So in 14.6, I saw a number first that wasn't 0. So technically, he's considered a large number. And what exponent goes with large? Positive. Now I still have the times 10 to the 9th. So now, what I do is I just make a combination of my 10s. So I have 1.46 times 10, and this time I have 1 plus 9. So my final answer is 1.46 times 10 to the 10th, and now Krill comes back in. Okay? So what we need to do is kind of, put that away please. What we need to do is look at what kind of number did I have. So for our definition, a large number is a number that's greater than 10. And large numbers that are greater than 10 have positive exponents. So if I have a large number and I need to move it over so that I can get my decimal part to be between 1 and 10, it's going to be using a positive exponent to make it move from that double digit to a single digit. Okay, so that's the part that gets a little bit confusing. And we're talking again about that 14.6. That's considered a large number. Okay, let's do one where it's small. Let me think. What if my numbers that I want to multiply are 3.2 times 10 to the 5th, and let's see, can I get one that's going to be less? Yeah, I don't think we'd ever get one that's less. I think that's going to happen in division. In multiplication, we're either going to get one that is between 1 and 10 or one that's over 10, and we're going to have to convert it. But let's deal with one with an exponent that's not positive. So I've got 3.2 times 10 to the 5th, and I want to multiply by 1.4 times 10 to the negative 17th. So again, the problem breaks down into two major components. I take the exponent, or the coefficient part is the decimal piece, and I'm going to actually multiply those. So I have 3.2 times 1.4. The next piece is going to deal with the powers of 10. Since the bases are the same, I've got a times 10. I'm going to take my exponents and I'm going to add them. So here I'm adding 5 and negative 17. So off to the side, I just want to know what 32 times 14 is. and I go back and I count how many digits after the decimal my original numbers had. There's 1, 2, so my answer will also get 2. Now, did I get a number that was between 1 and 10? Okay, so that means I'm not going to have to do any shifting. And what's 5 plus negative 17? Negative 12. As long as my front number is between 1 and 10, I'm done. And that's the answer there.